Welcome to 1D Kinematics, Introduction to Kinematics. Kinematics is the study of motion. It is the study of how objects move. When you're driving in a car, the speedometer will tell you the car's speed. And as you push down on the accelerator, the speed changes and the speedometer reads that. This value is based on the distance the car travels in a certain amount of time. This quantity is instantaneous. This is a good, as you read this, there's certain terms that you should put into your vocabulary sheet, and this is one of them, instantaneous. I know you probably already know what that word means, but this is an important distinction as we move forward. That means the speedometer shows that the speed at the particular moment, if the car changes speed, the value of the speedometer will change. To find the average speed of your trip, you would need the odometer. Now, this is not a term that you need to put into your physics terms, but this explains the concept of the difference between instantaneous and average speed. So in order to find the average speed, you would need to know the total distance you traveled and the total time it took. So you would use your odometer to know how far you have traveled, and you would use, a clock or whatnot to determine the total time of the trip. And given those two things, you can determine the average speed. Speed tells you how fast an object is moving, but not in which direction. Speed, distance, and time are all scalar quantities. So here's our second term for our definitions, scalar. A scalar quantity is something that just has magnitude. So when we say we're going 50 miles per hour, we just know how fast something's going. And if we say it took 5 hours to drive to San Luis Obispo, we just know that it's 5 hours. We just know it's a magnitude, okay? A scalar quantity has a magnitude, but no direction. We say that we are traveling at 100 kilometers per hour for 4 hours, or by looking at the odometer of the car, see that we've traveled 400 kilometers. These values have a magnitude, but there's no direction associated with that. If we say we're traveling 50 miles per hour, you don't know if you're traveling if somebody's traveling 50 miles per hour north, south, east, west. It's just 50 miles per hour. Physicists are often concerned about direction, though. So now they've introduced a new thing called a vector. Quantities that have a magnitude and a direction are called vectors. So some terms or whatever, and so vector is another term that you should put in your definition sheet, vectors. So some example vectors are position, displacement, velocity, and acceleration. Okay, we're going to be going over these one by one, so don't worry too much about that right now. Now, when you write about a vector, if you're writing a vector quantity, you're going to first write the magnitude of that vector, then you say the unit of that vector, and then you write the direction, and there's an example on the next page. So when writing the variable associated with a vector, that variable has a vector arrow, sometimes called a vector hat, above it. So for example, velocity is one of our examples of a vector, okay? So if we have V for velocity, that has a little hat on top of it. Speed and velocity are very similar, but speed does not have any direction. So for example, if we said a car was traveling 50 miles per hour, that would be speed. But if we said that a car is traveling 50 miles per hour heading north, that would be a vector. And the way we write it is we first write our quantity, our magnitude, then we write the units, and then we write the direction. Think of it this way, vectors are going places. They have direction, so they need to wear their hat. There are many different types of vectors in physics. We've already kind of listed them once: position, displacement, velocity, acceleration, force, momentum, field strength, etc. In this unit, we'll be focusing on position, displacement, velocity, acceleration vectors. The first two that we're going to be talking about today are position and displacement. So here we have position. Notice that position and displacement are both represented with, I'm going to change this, with a D. See, they both have D, and they both have the little vector hat, so they're both vectors. So position, and these are two terms that should add to your definition list. Position is the location of an object relative to a reference point. So here we have an example. We have a flagpole right here, which is our reference point right here. And we have a person, and this person right here happens to be standing 5 meters east of our flagpole. So when we write that, we write D here with our vector arrow. That's how we represent position. That's the variable we use to represent position. We have our magnitude, which in this case is 5. We have our units, which in this case is meters. And then we have our direction. Now, displacement is the change in position. So you can see that in our example down here, our gentleman started at this position here and then traveled to this position. So displacement is how he moved relative to where he started. Now you can see that we have our D, which is talking about, position, and then we have this little triangle in front of it. This triangle is a Greek letter, and it's called delta. Delta means change in. So when you're talking about delta D, then let me change my pen to a darker color. When we say delta D hat, it's talking about your change in position from 1 to 2. Now, anytime you're doing change in position, you always do D2, position 2, minus position 1. Okay, so here we have position 2 is 7 meters east minus 5 meters east. And so the resultant is going to be 2 meters east. And you can check that out because you can see that he ends up 2 meters east from where he started. Just like when you're doing slopes and graphs of lines and whatnot, and you're doing the slope equations, you always do 2 minus 1. Okay, so here's an example. This street scene helps to illustrate the difference between distance and position. We're going to set the reference point to be the cinema. So this is our cinema, and that's where you're going to start. And it says you exit the cinema and after watching a movie. So you exit and you're just standing right here. So it says, what is your position and what total distance have you traveled? Now, are both of these, position and distance, are both of these vectors? What is position? Is position a vector? Yes, position is a vector. Okay, remember it's symbolized with that. What about distance? Is distance a vector? No. It's just a magnitude. So that has no hat on it. So go ahead and answer these two questions. Okay, so let's look at our answers. So what is your position? Well, if you start here and you end here, your position is going to be 0 meters. Now notice that there's no direction here. And the only time a vector would not have a direction would be when the magnitude is 0. Okay, because it's not obviously not east, west, north, or south, it's right where it started. Okay, what is the total distance you have traveled? Have you moved anywhere from the cinema? Nope. So you can see that the position, which is a vector, is 0 meters, and the distance is 0 meters. So this is an odd situation where both the vector quantity and the scalar quantity are identical. Okay, so now it says, okay, so we started at the cinema, and now it says you walk to the post office. So So you started at the cinema and now you're at the post office. So what is your new position and what total distance have you traveled? So go ahead and answer those two questions. Pause the video if you need. All right. So our new position when we're here relative to here is we're 23.4 meters, right? That's our magnitude is 23.4. Our units is m for meters. And our direction is east. Okay, what total distance have you traveled? It also is 24 meters, but you can see that it does not have a direction. Okay, so here the magnitudes are the same, but you can see that the position, which is a vector, has a direction, and the distance does not have a direction because it's a scalar quantity. Okay, so now it says you walk back to the cinema. So you started here, you walked over to here, and then you walked back to the cinema. What is your new position? And what total distance have you traveled? Pause the video and fill those in. Okay, so your new position is 0 meters because you're back where you started, right? Relative to the starting point, you have not traveled at all. But what is your total distance you have traveled? Well, if you started here and you walked over to here and then you walked back, you've taken a lot of steps, right? You've traveled a total of 23.4 plus 23.4. You get it twice. So that would be 46.8 meters. Okay? And again, you see this is a vector and this is a scalar. Okay. So now it's asking for, it says you walked to the bakery. Okay, so you started here, you walked to the post office, you walked back to the cinema, and then you walked all the way over to the bakery. So what is your new position? And what total distance have you traveled? Pause the video and then solve those. Okay, the total distance your new position is now that you're here, and this is the beginning position, you could add these two up, which adds up to 61.1 meters. So you're 61.1 meters east of the starting position. But what is the total distance you've traveled? Well, here you traveled 23.4, and then you traveled 23.4, and then you traveled 23.4, and then you traveled 37.7. So you travel 23.4 plus 23.4 plus 23.4, because you did it 3 times, plus 37.7, right? So the total distance that you've traveled is 107.9 meters. Okay, this street scene helps to blah, blah, blah. Remember, position is relative to a reference point. Okay. The first scene helps to illustrate the difference between distance, position, and displacement. Set the reference point to be the post office. So now our reference point is the post office. You exit the cinema after watching a movie. Okay, so if this is our reference point, maybe we do our different colors. Maybe we do the reference point in pink. And so we start here, or right here. Relative to the reference point, what is your position? And what total distance have you traveled? Pause the video and answer those. Okay, with this being the reference point and this being our starting point, the position is relative to the reference point. We're 23.4 meters. Are we west or east of the post office? We're west. So now you can see that the position is west of the reference point. And what total distance have you traveled? You've traveled 0 meters because you just came out of the cinema, right? You haven't gone anywhere. Now, here we say you walked to the post office. Okay, so you started, remember this is this is still our reference point, but this is where we started, and then we walk to the post office, already here. What is your new position? What is your displacement? And what total distance have you traveled? So now we're introducing displacement. Okay. Remember, displacement is how far you've moved relative to where you started. Pause the video to get the answers. Okay, here, what is your new position? So, with this being our reference point, and we started here, and we walked over to here. So relative to our starting point, the new position is 0 meters. What is your displacement? Now remember, displacement is our delta D naught, which is our D2 minus D1, right? So our D2 is here, and our D1 is here. Okay, so we'll spell that. So this is going to be where we ended, is 23.4 meters, and if this is where you start and this is where you end, you're ending east from where you started. So it's 23.4 meters east. And what is the total distance you have traveled? It's 23.4 meters. Okay, now you walk back to the cinema. So this is our reference point. I'm going to use a different color. We start here, we moved here, and then we walk back to the cinema. Okay, what is your new position? What is your displacement? And what total distance have you traveled? Pause the video. Okay, so your new position is what? So you're ending here. This is the ending point, right? So your new position relative to where it started, relative to our reference point. So our reference point is this. So relative to the reference point, you're 23.4 meters west. What is your displacement? Now remember, your displacement is relative to where you started, right? So here we started at the cinema and we ended at the cinema. So our total displacement is 0 meters. And what is the total distance you have traveled? Well, that's how many steps did you take? So you made steps going this way and then you made steps going back for a total of 46.8 meters. This street scene helps to illustrate. Okay, now you walk to the bakery. So this is the reference point. We start here, we went here, we went back here, and now we're going to walk all the way over to here. So what is your new position? What is your displacement? And what total distance have you traveled? Pause the video and answer those. Okay, your new position, so this is your new position is here, and relative to the reference point, which is here, you're 37.7 meters east. Your displacement is how far you've gone from where you started. You started over here, right? So your displacement is 23.4 plus 37.7, so that would be 61.1 meters, and you're ending up east of where you started. And what is the total distance you have traveled? So for that, let's pick a different color here. We have 23.4, and then 23.4 again, and then 23.4 again, and then 37.7, which gives us 107.9 meters. I know this is getting kind of old, but it's good to get lots of practice on this. All right, so now you walk back to the cinema. So let's do this again. This is our reference point. We start here, we went to here, we walked back to here, we walked over to here, and now we're ending here. So here's where we ended and here's where we started. What is your new position? What is your displacement? And what total distance have you traveled? Pause the video and answer those. Okay. So 1, 2, 3, 4, 5. So your new position, this is where you're ending, right? So the position is relative to where you started. It's 23.4 meters, and this is west of where the reference point. Your displacement is, here's where you started, and here's where you ended. It's supposed to be on the same spot. So the displacement is 0 meters. And the total distance you've traveled, it was the distance from before, which I forget what it was. It was 107.9 was what we had before, right? So 107.9, and then now we have to add going all the way back. So 107.9 plus 37.7 plus 23.4 brings us all the way to 169 meters. Okay, remember displacement is the change in position. When the starting location and the ending location are exactly the same, the displacement is 0. This means if you were to run an entire lap around an oval track back to the point where you started, your displacement would be 0. Any questions? That's it for this portion.